This video is on optimization problem, and here I have a sphere. Given the radius of the sphere is 10, and what I like to do is find a cone, find the dimensions of a cone, meaning the height and the radius of the cone, such that the volume of the cone is maximized. And so here I have a sphere with the radius is 10, and I want to fit inside the sphere a cone with the maximum volume. And so in this example, here I have the sphere radius of 10, and then here I have a cone right here. And right now the cone, the height, meaning the distance from the top here to the middle of the cone, is at 15.2. And so the volume, the corresponding volume is 1161. And so if I reduce the height of the cone, then the volume is going to change like this. And so we want the height and radius of a cone that will give us the maximum volume. So right now, as I decrease the height, it looks like the volume of the cone is just going to get smaller and smaller and smaller. And so it looks like the maximum volume that we're going to get is 1,241 approximately. And now let's look at the relationship between the radius of the sphere and the radius of the cone and see how they are related. And so here the radius of the sphere is fixed, or is given at as 10. For the cone, the distance from here, from the top of the sphere here to the middle of the cone, this is the height of the cone. From the center of the sphere to the top of the sphere, this is the radius. And so this is r. So let r be the radius of the sphere, and let r sub c be the radius of the cone. And so the distance from here to here is r, and then the distance from here to the center of the cone is the height. And so this segment right here, this orange or yellow segment right here, is going to be h minus r. And then the distance from the center of the sphere to the surface of the sphere, this is going to be the radius of the sphere. And then if we look at this right triangle right here, this is the radius of the cone. And so from this right triangle, we can see that it's going to be r squared equal to h minus r squared plus r sub c, or radius of the cone, squared. And then as I change the height, we see that it's always going to be this relationship right here. And so it's going to be r squared equal to h minus r squared is equal to r sub c, or radius of the cone, squared. And so right now the height is 13.2, and so h minus r, or this segment right here, is going to be 3.2. And then to figure out the radius of the cone, I would use this equation right here. And so radius of the cone is going to be the square root of r squared minus the quantity h minus r squared. And then using this equation right here, and then we can figure out what the radius of the cone is. So right now it's at 9.4741. And then the volume of the cone is just 1/3 times pi times the radius squared times the height. And so in this case, r sub c would be 9.4741, and then the height is going to be 13.2. And that will give us a volume of 1,240. Once again, the objective of this video is to find the find a cone with the maximum volume. And so, as we saw earlier, the maximum look like it's going to be when the height is about 13.4. And so now let's go find the exact solution, or the exact height and the exact radius of the cone that will give us the maximum volume. So once again, r here is the radius of the sphere, which in this case is given as 10. And then r sub c is the radius of the cone, and then h is the height of the cone. And the volume of a sphere is just 4/3 pi times the r to the radius to the third. And then the volume of the cone will be just 1/3 pi times the radius of the cone squared times the height. And then we have this relationship right here that relates the radius of the sphere and the radius of the cone. And then multiply this out, we get h squared minus 2hr plus r squared, and then plus r sub c squared equal to r squared. And then subtract r squared from both sides, then we get h squared minus 2hr plus r sub c squared equal to 0. And then move these two terms right here, move them to the right, and we get r sub c squared is equal to 2hr minus h squared. And so the volume of the cone, the r sub c squared here, we can replace it with 2hr minus h squared. And then simplify, we get volume of the cone is going to be 2/3 pi times h squared r minus 1/3 pi h to the third. And our objective here is to find the height such that the volume of the cone is maximized. And so what we can do here is take the derivative of v sub c here, of the volume of the cone, with respect to h. And so the derivative of v sub c is going to be 4/3. So here we're taking derivative with respect to h. 4/3 times pi times hr. Recall that r is the radius of the sphere. In this case, this constant is fixed at 10. And then minus pi h squared. And then we're going to set this equal to 0. And so we get 4/3 pi hr minus pi times 10 minus pi h squared equal to 0. And then solve this equation right here, solve for h. Then we get h to be 4/3 r. And so what it means is that to get the maximum volume right here for the cone, and then we must let h be 4/3 times the radius of the sphere. For this particular example, and then we must let the height be 4/3 times 10, which is 40 thirds, or about 13.33. And we saw that here. The maximum, the cone has a maximum volume when the height is about 13.4 here. But the exact answer is 13.30, 13 and 1/3. And now that we now that we know what the height of the cone should be to get the maximum volume, we could also figure out what the radius of the cone is, because the radius of the cone is, we can use this equation right here. And so from this equation right here, we get r sub c squared is equal to 2hr minus h squared. And then in the place of h, we have 4/3 r. And then simplify everything, we get a over 9 times the square of the radius. And then the maximum volume of the cone is going to be 1/3 times pi times the r sub c squared. In this case, is going to be 8/9 r squared. And then the height is going to be 4/3 r. And then simplify everything, we get 32 over 81 r to the third. And so for this particular example, r would be 10. And so the largest volume is going to be 32 over 81 times r to the third, which is 1,000. And that's the end of the video.